Continuing our journey from console and batching to automated IDEs, today we're going to create a project workspace. In Notepad++, click on the button titled Folder as Workspace and drag the source folder into it. Next, go to Run and enter the path to our run script, then bind it to a hotkey. Myself, I settled on the keys Ctrl, Shift and F5. In essence, we want to automate our compilation and run process to make it quicker. Our dependable old batch runner comes in handy here, albeit with a facelift. As we are up to the point of making a 2D game, we need to make some 2D art. Simply go to your favorite search engine and search for GIMP. This open source drawing tool is entirely free and perfectly functional for our needs. As will hopefully become apparent soon, our first game character will be a tank. It will be comprised of 3 parts, put together using our entity tree. The main body, including the tracks, will be attached to the root entity. The turret will swivel on top of it in a child, and the gun barrel will be attached to the turret via a third or grandchild entity. Now that we have a 2D sprite, we want to update the code to actually load and draw it. Up until now, our Sprites2D class has simply been placeholder, in that it would draw an X shape wherever it was placed. We now replace this with some image rendering code, including support for texture or UV coordinates as they're otherwise known. Now all we need is a simple image loading subroutine and we are ready for our very first test run. With our image rendering properly, we now use our texture coordinates to sample the correct portions of it. Here it is handy to use GIMP's rectangle select tool to get the correct coordinate values. With our base tank entity now drawing and behaving properly, we do a little happy dance. Now it is time to turn our flat list of entities into a tree structure. First, we allow our entities to have children and grandchildren by giving the entity class a list of child entities. Next, we update our Game2D class to iterate over these descendants and their components. This will allow us to have a gun barrel attached to a tank turret, all sitting atop a tank chassis. In order for our turret to stay attached to its parent, the tank, we need to implement a mathematical technique called matrix multiplication. In simple terms, this is the act of concatenating positional, scale, and orientation information of one object and another. With our tank fully assembled, it is time to give it some behavior. We shall start with a simple rotator component added to the turret. Next, we shall give our tank some mobility. To do this, we create a class called Tank Driver and add it to the main body. Up until now, our movement components have performed a fixed step every frame. This quickly becomes unrealistic, as slower computers will be running our game in slow motion, while faster computers will be running in fast forward. To alleviate this, we implement a technique called time delta. This is simply a measurement of time, often in seconds, between the last frame and the current. We then use this value as a multiplier of linear and rotational velocities that are conveniently stored in either meters or degrees per second.